All right, terrific seventh graders. Always better when you're here with us. Thanks for being here. Glad to have you. Today I want to teach you about how to use representative samples to make predictions about populations. So if you'll make this the title on the next free page in your math notebook, leave yourself lots of space. There's going to be a page should be enough. And after you've gotten that written down, unpause, look, listen, and think with maximum effort, and then we'll write when we get to we do. Since this is about representative samples, let me start with a reminder of what those are. Let's say I wanted to find out like how tall students in an elementary school were. Elementary school, I'll just abbreviate. So if I wanted to answer that question, and that's called a population, right? The whole school is the population, or the whole country, or the whole group, or whatever the total group of people are. And it's often not reasonable to ask or sample or every single person in the whole school or the whole country or the whole whatever. So we use what are called samples, which are smaller groups of people or things to try to get information about the whole thing. So when we make a sample, it's important that the sample be representative, that it be random people. I'm not just picking certain ones because then I'm likely to get a bad sample. And that it be people that represent everybody. Right? That's why it's called representative. You wouldn't want to get a not representative sample, like let's say one kindergarten class. Right? If I want to know how tall the students at a school are, and I just measure the kids in one kindergarten class, that is not going to be representative because they're likely to be smaller than average students, and so I'm only measuring smaller students. That wouldn't be representative. We would want to do something like one student from each homeroom. Something like that. Then it's random. I'm not like picking certain students that are tall or short or whatever. And it is representative of everybody, one from like every class and every grade. So that's what representative and not representative samples are. So let's talk about how we use that information to make predictions about a population. So let's say a teacher asked one student from each homeroom how long it takes them to get to school. And here's what they said. See how many that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it looks like there are 24 homerooms. So if the whole school has 720 students, can you use this data to estimate how many of them would say it takes them more than 10 minutes to get to school? Okay, so here's what we're going to do. So looking at my sample, there are 24 students. And let's see how many of them said it would take them more than 10 minutes to get to school. 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to include 10. 10's not more than 10 minutes. That one. So how many was that? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Did I miss any? Double check. No. So 9 out of the 24 students in the sample take more than 10 minutes to get to school. And this is a pretty good representative sample, right? One student from each homeroom, randomly picked, pretty good. So 9 out of 24, how many in the whole population of 720 would we figure need a long time to get to school, need more than 10 minutes? So you'll notice this looks like a ratio probably. So that's how I'm going to treat it. So I have lots of ratio strategies. I tend to most often use this one called the proportion strategy. It's already set up. So if 9 out of 24 in my sample take more than 10 minutes, how many of the full 720 would I expect to take? Well, let's see. 24 times what is 720? Don't know. Let's see. 720 divided by 24 is 30. So that is 30 times as many students. So probably 30 times as many would take that long to get to school. So 9 times 3 is 27 plus a 0. So probably around 270. Just like probability, when we talk statistics, we're making, remember, a prediction or an estimate here. So keep in mind, this isn't a strict ratio. This is just an estimate or a prediction, but it's probably close to this. Probably around 270. Doesn't mean if it turned out to be 275, we did something wrong. It's just a representative sample may not give you the exact, perfect, exact number, but it gets you a good estimate or a good prediction. I do want to make sure when you look at this kind of question, especially if you're good at math and you see numbers and you know what to do, something to watch out for. I'm going to put almost the same question up on the screen. Same data, same question, 10 minutes. But read the sample carefully. I changed the sample. A teacher asked all the students who walk to school, rather than one student from each homeroom, asked all the students who walk to school how long it takes them to get to school. How many of the whole 720 would say it takes more than 10 minutes? Now we do not have a good sample. I don't think it's representative to assume that the walkers are a good representation of the whole school for how long it takes to get to school. Now we know how long walking takes, but hardly anybody walks, it looks like, only a few students at the whole school. So even though we still have 9 out of 24 in the sample, now it is not representative. So we cannot make a prediction about the population. It's not enough just to have a sample. It has to be a representative sample, and that's really important to forget. So you've got to analyze your sample first in order to do that. All right. I'm going to give you a printout of the We Do tomorrow. So unless you're doing this just for your own sake, I know this is a lot to copy down. I'll give you a printout of this tomorrow if you're in my class. So don't worry about writing this all down today. Let's do this one together. So here are the results of a survey of 20 people who read The Adventures of Super Sam regarding what special ability they hope the new hero should have. And there they are. So a survey of 20 people, probably a sample. If there are 2,024 dedicated readers of The Adventures of Super Sam, estimate the number of readers who will want the new hero to fly. So looking at my sample here, there's a lot. There's 2,024 readers of this book or this comic book, whatever it may be. How many want the new hero to fly? So we have a sample of 20. I don't know who they sampled, but it would be nice if I saw the word random in here, of a random 20 people. But I don't see anything in here that makes me think it's not a good sample of the group. 20 people who read the book out of 2,024 people who read the book, so probably fine. So in my sample of 20, we want to see 2024. So let's see how many want the new hero to fly in what we have so far. I see 1, 2, 3, 4, 5, 6, 7, 8. So it looks like 8 out of 20 people in the sample would like the new hero to fly. So how many would we predict or expect or estimate out of the full 2024? Let's find out. So 20, I don't know this off the top of my head. 20 times what is 2,000? Oh, I actually probably could do it, but I'll spare you that. So it's going to be a decimal, I believe. 2024 divided by 20 is that. So that's 101 2/10 as many people. So I'm going to multiply that by the same. I'm just going to leave the number in my calculator and do times 8. So got a decimal, right? So obviously I'm not going to have that exact number of people because you can't have a fraction of a person. But remember, this isn't the actual number of people that are going to do this. This is a prediction or an estimate. So it's okay to leave that, even though it's obviously impossible for 6/10 of a person to do that. So we would expect somewhere around 809, 810 people-ish. It may not even be exactly one of those, because remember, this is an estimate, not an exact number, but probably somewhere around 810 people to want the new hero to fly. Careful, as I'm going to remind you, I'm going to give you this page too. Almost the same slide. But check out my question now. I kind of changed this part. This is the same. This is the same. But here I said, if you asked 1,000 people what special ability they think would be the most fun to have, how many do you think would say fly? So my population's 1,000 now. Still the same, 8 out of 20 want the superhero to fly. But you'll notice this and this are different. They are not representative. Right? Just because 8 out of 20 readers of this book hope the new character will fly, that doesn't mean if you asked 1,000 people what they would like to do themselves would say fly. It's not representative sample. We can't make a prediction based on the data we have. Not representative. So you've just got to be careful before you do any of these questions. If you're good at math and you don't want to just jump into the numbers, you're like, oh, 20 times whatever's 1,000 and I can just do it. First thing to do is make sure you have a representative sample, because if you don't, you're just wasting your time doing the math. It won't be a good prediction anyway. All right, y'all. That is how you use representative samples to make predictions about populations. I hope this made sense to you and you feel confident. Some ways to tell. Can you tell if a sample is representative of a population or not? And if it is representative, could you use a ratio strategy to make a prediction about the population? If you feel good about those two things, you're probably in good shape for class tomorrow. If not, I would recommend watching this video one more time, brain turned on, and really take it in. See you tomorrow.